right, guys, yesterday, which for me is the same day because I had to take a half day Monday so that I can go move. Um, that's why I'm wearing the same outfit, but it's Tuesday for you now. And yesterday, which was Monday, you learned that there are three states of matter that we're going to focus on in fifth grade. We know that there's isoplasma, and we will talk about that. And scientists are discovering new things all the time. And the three states of matter we're going to focus on are the solid, liquid, gas. And in a solid, we know what makes it a solid is the molecules are packed tightly together, like this table. Okay? We know that a liquid, the molecules are further apart, and they roll over each other, like a liquid. Okay? And then we also learned that a gas, the molecules have a lot of energy. There's that E word, and we're going to talk about that soon. And they are the furthest apart, and we can't see gases because the molecules are so far apart and moving around. And here are, in this PowerPoint that I will have on the website under materials, you will see that there are a couple songs if you want to practice at home. When I was becoming a teacher, and I had my first class with a mentor teacher, and it was second grade, and I would sing some songs during our reading lessons. And on the last day, we had a party, and my mentor teacher said to me that one of the things that she would recommend for me is not to sing in front of my students. And she said it jokingly, but that tells you what kind of singer I am. So I'm not going to sing along, but this one goes to the Wheels on the Bus. And here's another Matter song, which I won't sing for you. All right, here are some examples of their solids, liquids, and gases. We know that milk is a liquid. The air inside this hot air balloon, of course, is a gas. And I told you yesterday that we were going to learn what happens when you heat up matter or take heat away from matter. So here's a little chart that you can refer to. We know that when a solid melts, it becomes a liquid. You know, you think of, an ice cube. It melts and it becomes water. Okay? Condensation is when a gas becomes a liquid. All right? So if there was some cold water, or if there was some cold water in here and the air around me is warm, then it's going to get wet on the outside. And that is going to be condensation, because what is happening is the water vapor in the air is losing its heat, and it's turning into little drops of water. So it is becoming a liquid. Freezing is when liquid goes to a solid. So if you put some water in the freezer, it's going to become an ice cube. Evaporation is when liquid turns to a gas. Okay? In the first lesson I just taught you, I spilled some water here. Okay? I'll probably leave before remembering to wipe it down. But when I come back to school on Monday, it's not going to be there, because eventually that water is going to evaporate. That liquid is going to turn to a gas, and it's going to become water vapor in the air. Sublimation is when a solid, like this, turns to a gas. It goes straight to a gas. All right, now, matter can change. Once matter is here on Earth, it is here to stay. Okay? So this piece of paper right here that I wrote down little jotted notes on for your Sanford Harmony lesson. This piece of paper is here on Earth. Okay, so unless, of course, it makes its way to on a trip to space, it's going to stay on Earth. Now, do you think 100 years from now it's going to look like this? Definitely not. So matter can change, okay, but it's going to stay here on Earth, but just in a different, it's going to look different. So there are two types of ways that matter can change. There's physical change, and there is a chemical change. Okay, so physical changes, we have here some lists of the physical changes, and here we have a list of chemical changes. And I'm going to go ahead and explain to you what a physical change is. A physical change is when something becomes different in size, shape, appearance, or state of matter. It is a change that can be undone, and it does not produce a new substance. Okay? I'm going to take this paper as an example again. Okay? Have I changed it? Yep, I have. But have I produced a new substance? Is there something new that wasn't here before? No. It's the same piece of paper that there was before. Nothing new is made. It's just in two pieces. Okay? I can keep on doing it. But if I had all the time in the world, I could put it back together and undo it. I'd have to get some tape too, but I could put it back together. So a physical change is a change that does not produce a new substance, and it can usually be undone. For example, ice melting to form water. Let's say I have an ice cube in my hand right now, and I'm talking for hours, and eventually it melts. Okay? If I put that back into the ice tray, that water, it's melted in my hand, and I put it back into the ice tray, put the ice tray in the freezer, and it freezes. Okay? I've undone it. Okay? I have been able to put it back into, I have been able to make it back to what it was before. All right? And it also didn't produce anything new. It's still the same molecules that made up the ice cube, but when they got heat added to them and they got energy, those molecules moved apart and became water. And we will continue talking about that. A piece of glass breaking, and I unfortunately do that all the time. If glass breaks, a plate breaks, and now it's in a million pieces, it's still just that same one plate, it's just in smaller pieces. You didn't produce anything new, so that's a physical change. Blowing up a balloon, that is going to be a physical change, because as soon as you let the air out, the balloon's going to go back to what it was before. Shaping clay into different shapes, or playing with Play-Doh. You know, you're always making different shapes and doing different things, and that is a physical change, because something new is not produced, and it can be undone. Now, chemical changes. A chemical change is a change that cannot be undone, and it produces something new. Okay? So, some examples we have are decomposition, photosynthesis, rusting, ripening, cooking. Right? Ripening. Let's say I had a nice, yellow, delicious looking banana, and I left it on my desk on Monday, and I decided to go get chips instead of the banana. On Tuesday, I decided to get a candy bar instead of the banana. On Wednesday, I skipped snack. On Thursday, I had some pretzels. So Friday, I'm like, okay, I'm going to be healthy, and I'm going to eat this banana for snack. Well, is my banana still going to be yellow? No, probably not. It's going to be brown, and there's going to be spots that I might want to eat around. And if I left it over the weekend, it would be really brown because it ripened so much. Now, can I take that brown banana and change it back to that yellow banana I wanted to eat one day? No, I can't. That is a chemical change. It cannot be undone. And it did produce something new. It changed the color of the banana. It turned it brown. So that is a chemical change. We are going to keep talking about physical and chemical changes, and tomorrow, and I'm going to have a cool little experiment for you guys to see with it. But for now, I want you guys to take out those notes that we started yesterday. I'm going to have to go press escape on my computer. So while I do that, you can get your notes out, get your pencil ready. All right, so we can write changes in matter. We will write physical change first. And remember, you can pause this video so that, if I'm going too fast, you can pause it so you can get all your notes written down. So, physical change. Well, what is a physical change? It is when something changes, but it does not produce a new substance, and it can generally be undone. So, for the definition for physical change, a change in matter that does not produce a new substance and can usually be undone. Now, chemical change, I actually just paused there. I forgot that I don't have a class of students. So I actually did my normal pause and then saw my reflection and remembered I'm just teaching to the iPad right now. All right, a chemical change is a change in matter that produces a new substance that wasn't there before and cannot be undone. All right, so some examples of physical changes. Okay, anything in the water cycle is a physical change. You can take water and put it in the freezer and it freezes. But if you take it out of the freezer, it's going to go back to the way it was before and be that water. And, so anything, even this water that is going to evaporate, right? If I were to then take all the heat away, then it could be back as a puddle of water again. Okay, so anything in the water cycle is a physical change. Ripping this piece of paper in half is a physical change. Molding clay or Play-Doh is a physical change. Glass breaking and shattering is a physical change. Breaking a pencil is a physical change. Anything that didn't produce something new, and if you had all the time in the world it could be undone, is a physical change. A chemical change is a change in matter that produces a new substance, something that wasn't there before and can't be undone. So if I were to bake a cake and I'm going to put in some flour, some sugar, some milk, some oil, some eggs, and I mix it all up and I put it in the oven and I bake it, and I take the cake out and it smells good, but I remember that I needed those eggs for tomorrow morning. Am I going to be able to take those eggs out? No. So that can't be undone. That is a chemical change. The ripening of that banana is a chemical change. When you leave your bike out in the rain and it rusts, that is a chemical change. You might be able to sand that rust off your bike, but that rust is still there. It's just maybe falling to the ground. So tomorrow, we're going to have a little experiment and show another difference of physical and chemical changes and keep talking about physical and chemical changes. All right, have a good day.